Okay, today we're going to look at section 4.2, triangle congruency by SSS and SAS. I'll explain what that means in just a minute. So in section 4.1, we used some theorems to prove that figures are congruent by showing that all the matching sides and the angles are congruent. And we can use that anytime we want for any figure. But in section 4.2, we're going to look at some special cases for triangles that we can use to prove congruency of triangles. The first one is postulate 4.1, the side-side-side or SSS postulate. So in this theorem it says, or postulate rather, it says if the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. In other words, we don't have to prove anything about angles if we can show that all three sides are congruent. So let's look at using this. And if I give you, if I give you this diagram, and I call this P, N, L, M, and if I give you information from the diagram that looks like this, we can do a proof that we want to prove that triangle PNL is congruent, PNL, to MLN triangle. Okay, so the first thing is given from the diagram. PN is congruent to LM, and PL is congruent to NM, and that's given from my diagram. The second thing I'm going to do is I'm going to say that line LN is congruent with line LN. And that's the reflexive property of congruency. And now I can say that triangle PNL is congruent to triangle MLN by the side-side-side postulate. So it's a pretty easy postulate to use, just proving that three sides of a triangle are congruent proves that the two triangles are congruent. Okay, the next way we can prove that triangles are congruent is the 4-2 postulate, the side-angle-side postulate. And this says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So let's see what we mean about included angle. So if I have triangle ABC and I have another triangle, I'm going to draw it a little bit different alignment. So if I have another triangle that looks like this, and I'm going to call that DEF, if I can show that AB is congruent to DE, and BC is congruent to EF, and that their included angles are congruent, then I can prove that the triangles are congruent. Okay, so that's the idea behind this one. We will not do a proof of this in the video, but we'll work with this in class. So two sides, two adjacent sides, have to be adjacent in a triangle, and the included angle. So if, in other words, I prove I have a diagram that looks like this, that is not enough to prove congruency. It has to be the included angle between the sides that are shown as congruent. All right, and that's it for the video.